So hi everyone, welcome and thank you for joining us today. So I will just introduce us a little bit. So we're Women in AI and we're a global organization and we're present in all over the world. And in Ireland, we currently have around 20 volunteers delivering various programs. So I'm one of them. My name is Andrea Balog. I'm a PhD student in UCC. And today, Nabanita Roy will be talking to us. She's a data scientist at ACI Worldwide. And the aim of these series of tutorials is to help beginners and industry professionals to transition into AI. And we're planning on doing this with short tutorials that introduce tools and concepts of AI. So today, Nabanita will talk to us about some Python tools, and I will let her get started now. Thank you.
Thank you, Andrea. Thank you very much. To everyone, welcome to our first session of WAI tutorials, and we are starting with the basics, tools for Python. Just to start with, let's look at why Python. What is the big deal about Python? Python is the most popular language of today. It's used for a lot of things. It's versatile. It's used for web development. It's used for automation and scripting. It's used for software testing and also prototyping. You can use it for automating everyday tasks, like if you want to send an alert to your phone, if you want to automate sending emails, or if you want to keep an eye on the movements of the stock market, if you have been investing in it, Python gives you everything that you need to do. Python, especially for artificial intelligence or data science, Python has extensive libraries that can be used for data analysis and machine learning, which forms a small part of artificial intelligence. Artificial intelligence is much more than data science. It allows you to process speech, to process images for autonomous cars, and Python gives you all the tools to record and synthesize texts, to process images, to take real-time images. Python gives you the ability to encode all of this, package it in a software, and publish it. And Python is also beginner friendly. It's very simple. And that is why Python is the fourth most used languages for people who are starting out the coding journey. It ranks fourth after HTML, CSS, JavaScript, and SQL, which is understandable. And it's also the third most used language after JavaScript and HTML, CSS for professional developers, from a survey that Stack Overflow does yearly. And in 2022, Python was all over their top 5 technologies. And also the IDEs, for example, PyCharm and Visual Studio, they ranked very high in these surveys. So Python is the way to go. And now, when we're talking about Python, there's some place where we have to write the code, right? So integrated development environment, or IDEs, is where you basically code any programming language for any programming language. And these IDEs are basically a software suite that basically consists of the tools which are required to build a software. And when you want to build a software, you need to write code. So the code editor is there. You have code libraries, which contains all the information about the modules and submodules. And
sorry, Nabanita, just one second. Your slides are not changing.
Is it not?
No. It's still just showing the first one. Yeah, now it's changing. Perfect.
Is it? Okay.
So now the integrated development environment is showing.
Oh,
great.
All right, thank you. Just remind me if it doesn't change the next time.
Yeah.
Okay.
Perfect.
And so these code editors are rich text editors. When you write, when you declare a class, when you declare a variable, the color codes are different. So it basically helps the developers to write efficient code. It also, most of the modern IDEs, they are well equipped with IntelliSense. So it gives you code suggestions, automatic code completions. It tells you if you're using the best practices and the best coding standards. If not, it automatically changes your code, and you can always do Control Z to go back to what you've written down. So these code editors and code editors are really helpful for developers. Since programming languages need to be compiled or interpreted, most of the IDEs, all IDEs will have a compiler or interpreter. Python is an interpreted language. So PyCharm and other IDEs for Python, they have an interpreter with them, a debugger for debugging issues and locating errors, and also a linker which says, if you've declared a class here and you've instantiated the class in a different file, it links and says that, this class was utilized in this file. And if you go to the other file where you have instantiated it, it lets you go back to the file where you have declared it. So these are all interlinked. And your IDE knows where exactly or what codes are you reusing and where you're reusing. And all these things, all these capabilities are inside one IDE. It gives you a single GUI or graphical user interface, and a developer doesn't need to go elsewhere to seek these capabilities. In an IDE, you will also find add-ons and extensions. For example, PyCharm is for Python. And if you want to have additional capabilities for JSON, XML, YML for markdowns, you can add on extensions, build automation tools, coding frameworks. So you don't really have to go to a browser and check the documentation and go through the modules and submodules. You have access to the document, to the modules and submodules, the documentation inside it already in the IDE when you load that programming language. You get error diagnostics as well. So when you build large applications, it's very difficult to debug code. So debugger and error diagnostics are very, very essential component of IDEs. And it lets you set a breakpoint and execute line by line. It gives you the ability to check the variables, the status of the variables at one instance, and see what's going wrong, probably in initializing those variables or reassigning those variables. And the last and most important, when you're collaborating in teams, version controlling is very important. And so, and sharing your shareability of your code. So integration with Git or say Team Foundation server, that is also a part of IDEs. And the most used core Python IDE is PyCharm.
Your slides are not changing, Nabanita, just to let you know.
Okay. It's changed now, right?
Yes, now it's on the 4th slide.
Okay, cool, thanks. And PyCharm is the most used one in the Python community. VS or Visual Studio is the largest, and it's still most extensively used. It supports a lot of programming languages, not just Python. So therefore, it's a bit more popular amongst developers. And Spider comes with Anaconda. And if you install Anaconda, you will readily see it. I haven't used it for a long time. I usually use PyCharm because of because of a lot of advanced tech tools that PyCharm has, especially the IntelliSense and the debugging interface, all those things. And so this is a part of this is one of those ways where developers has always been developing code. The revolution in coding when it comes to data science and data analytics comes with notebooks, which is a bit different from how you develop applications. These are mostly predominantly built for computational documents, for sharing computational documents and executing code, finding your analysis, interpreting your visualizations, and you document them in the same notebook or same place where you're writing the code. And notebooks gives you exactly that. So there are two most used notebooks. One is a Jupyter Notebook, and then we have Google Collaboratory, which uses Jupyter Notebook, the Jupyter Notebook project, but they have hosted it on cloud services. So when we talk about this, notebooks allows you to execute your code inline. So every time you execute your code, you can see what's out there in the variables. You can get inline visualizations as well, and everything on your browser. You don't need an IDE for that precisely. And also it allows you to document your findings, your headings, subheadings, basically organizing your entire notebook. And the way you do it is using the Markdown Editor. So these notebooks consist of cells. A cell could be a note, so a cell could be a code, and a cell could be a Markdown Editor, where you write down something in normal natural language, and the output for it is basically whatever you've written down. And in another cell, you can write your code and execute it, and it works like a Python code. And because these are documents and these are usually used for educational materials, developing blogs and stuff, you have the ability to export them as PDF or an HTML, and even as a .py file. So the difference between IDEs and notebooks is that IDEs works with, PyCharm works with .py files and different other files, but not with IPyNB or the IPython notebook files. So if you want to execute a Jupyter notebook in your IDE, it's not going to be possible just right now. I'm not sure if they're adding on to it, but at this point of time, you cannot execute Jupyter notebooks on PyCharm. So you need to have either Jupyter notebook, or you can upload your work on Google Colab and you can use it there. So these are the only types of tools that you can use for these notebooks, and you can export them as a notebook file as well from your browser, and you can upload and use it in whichever way you want. Now, Jupyter is open source, and because Jupyter is required to have a local setup on your machine, so you have to set it up from scratch. You need to install the libraries that you need. You need to set up, add your environment variables and everything, set up your local machine and your coding environments, as opposed to Google Collaboratory, where it already gives you an environment to work on. The only difference is, and to work with Jupyter Notebook, you don't need internet connection as long as you have downloaded and set up your environment. But with Collaboratory, you need a stable internet connection in order to deal with the Jupyter notebooks. Jupyter notebooks, they support over 40 programming languages, which includes Python, R, Julia, and Scala, whereas Collaboratory is a bit more focused on Python, and it's basically Python only, and only a minimal configuration is required. And the most important part of Google Collaboratory is that it gives you accessibility to free GPUs and TPUs for running your machine learning, your deep learning models, and it basically executes these files in seconds, whereas your normal computer without a GPU would take like some hours or minutes more time to execute these deep learning, to train these deep learning models. So that's about notebooks. And now we'll go into a bit of a demo with Google Colab, right? So this is how you can access Google Colab. Type Google Colab. That's the first link. It's basically a Google research product. And you can go to Google Collaboratory. You'll find something like this. It has, you can go and check your recent notebooks. You have some examples from Google. You can see your Google Drive for the files you have on your Google Drive. You can connect your GitHub or you can upload over here. So if you have something in Jupyter Notebook, you can download your notebook and upload from here. What we are going to do is going to create a new notebook. So you see, you can name your Google Colab notebook, and it automatically stores in your Google Drive. So if you need to have a Google account to do all these things. Here you can add your cells or text markdown. And to demo how we already have our entire environment set up, you can just do import pandas. So pandas is one of the popular Python libraries, NumPy, sklearn, in LTK. These are popular Python libraries. And and you see it imports all of these, and I did not have to go for pip install blah 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 all these repositories. So now what happens if I want to import something that is not popular? So this is one of the Python libraries which is not there in Google Colab. So we can easily do a pip install contractions, install it, and then import it. So it is that handy. So you don't really have to go back to your coding environment as you would do in your machine and install them and come back and refresh. So it's just all there. Import contractions and it should work. Apart from that, you can add text. So it's just clicking here on text. You can add a heading. You can add a heading. So that's how it's going to look. You can add a subheading with 2 hashes. And you can keep on adding. You can write some text. And you can also make something bold. It's bold. You can use italics. You can use bullets. And you can also number them. 1. And this is how you see how it did not detect the dot, so it did not come up. So, and it also shows on Google Colab how it appears on the right-hand side. Now that we have a heading and a subheading here, let's go here and see this sign is for table of heading, table of contents, and you've got a heading, you've got a subheading. So as in how you keep on adding more stuff here, your table of contents is automatically going to get built up on the left-hand side. You can also add, you can also see variables. For example, if I assign, say, text. And you can see the variable over here. So this is basically Variable Explorer. And here, this is basically the directory where you are at the moment. And you can access code snippets from here. You can open files from Google Drive. So you just need to put an insert over here and it works. You can also mount Google Drive from here. So if you do that, you have to connect to your Google Drive. So I am connected to my drive and I can access the contents on the left-hand side. So for example, if you've got some data set or some files that you have in your drive, and if you want to look up those, it'll all come up here. You can directly use them in your data set, in your notebook here. So, and you can also access, access data visualization. And can you see data visualization libraries? And you can see the automatic completion of these of the libraries. So if you click on that, it automatically populates it for you. See all this, and you can just load a data set and you can execute your normal Python commands, and then you can get a plot something, say total. So it lets you see, so in line, you're executing your code and getting the data visualizations here. Apart from that, you can check, you can change the runtime over here. So right now I'm not using any hardware accelerator, but I can use a GPU, I can use a TPU here. And this only accelerates your training deep learning models. And if you go here on Google Colab and look at your look at these tutorials, you can actually access some of the information. For example, if you want to try the text classification code here, you can go and run it on Google Colab, and you can change the runtime and compare without any GPU and with GPU, and see how long a time the training the deep learning model takes here. In this cell, it took about a few seconds when I used a GPU, and it took about 15 minutes to train this model without using a GPU. So that is the power of using Google Colab. You can easily share it with someone, and if you open it, and it gets added to your drive, and you can also save a copy on GitHub. So I can go there, click on the repository that you want to save it in, and if you have a path like that, gives you have a commit message, and then you can include a link to the Collaboratory and click OK, and it should create added to your GitHub over here. And we'll have a little button here that says Open in Collab, and you click on it, you find it on Collab. And it basically gets added to your drive when you open it. And similarly, you've got other demos as well on the Collaboratory page. Feel free to check it out. And let me know if you have any questions. That's where I end the presentation. Here are some of the references that I've used, and some of the references that you could use as well to go through the content. And if you have any questions, I'm open to questions.